Welcome to Akshar online classes. This is Gafar sir, your physics faculty. Let's start our session. So, is my voice is audible, Akansh? Yeah. So, last class we have been completed about what are the things, variation of acceleration due to gravity, due to height, due to depth, and also what is mass, what is weight, and what is free fall. These things we discuss. Based on these things, we do some questions right now. Understand? I will share for the questions. I'll share you the questions, so we can complete, so that we can complete this topic. These are the questions I am giving to you. Is it up here? Yeah, it is up here. Tell me, the force of attraction exerted by the earth on the body is called. What is the name? Yeah, you are right. What is the name? Gravity. So that is called gravity. The force of attraction exerted by the earth on a body is called gravity. Next, gravitational force is always. Gravitational force is always. What kind of nature? Gravitational force always. What kind of nature? It is a always attract. It can't be repulse. Because here, let us take this is a mass. This is a mass. This is m1. This is m2. Okay, this is m1 and this is m2. Between these two masses, always what kind of what will happen? Attraction force only existed. That is called gravitational force. But whereas if you see, this is a one charge, this is a one more charge. If these two charges are near to this is a similar kind of charges. What kind of force will existed here? Repulsion force is existed between the charges. If they are same nature, repulsion force existed. If they have opposite nature, what kind of nature will exist? Attractive nature. Even if you see, what magnets. This is a north pole. This is also north pole. What happened? Repulsion or attraction between them. Repulsion takes place. Whereas north to south, what kind of? Actually, this is nothing but magnetic force. Magnetic force. This is nothing but electrostatic force. Electrostatic force. And this is nothing but gravitational force. Gravitational force. So gravitational force, what kind of nature? Attractive or repulsive? Always attractive only. So next, gravitational force obeys Newton first law, Newton second law, Newton's third law, all of this. So tell me what? All of these are right. Okay, it will obey all of these. The value of the universal gravitational constant does not change from place to place. Changes with changes of place, become more at night, become more at during the day. Tell me. What is the option A? Does not change. Can you tell me what is the value of this G? G is equals 10 power minus 11 Newton meter square per kg square. This is a value for the capital G, and the units for the capital G are what? Newton meter square per kg square. And next, one more question. The universal constant gravitation G has the dash units. What are the units? So, option D. The value of gravitational constant. The value of option B is the correct answer. Next, force for interacting particles. We can write the principle of superposition for net gravitational force on the first particle due to remaining forces are. What are the thing here? What are the thing here? You will get this one. Understand? Next one. Not this. You will get this one. C1. Vector form it. Huh? Look at it. Good question. Look at here. Let me take this is a reference frame. This is a reference frame. Here we have a m1 mass. This is a way we have different masses. Okay. Now here to here distance is something r1. This is m2, and here to here distance is r2. This is m3. Here to here this is r3. This is m4. Here to here this is r4, and this is m5. This is the way many masses we have. We have many masses. Now between this m1 and m2, the force, let us take, see here, this is the way we have masses. Okay, here first mass is present. On this mass, due to these other masses, force is acting. Due to m2 mass, F12, due to m3 mass, F13, but directions we need to keep. Due to fourth mass, M14, this is the way many masses are present. This algebraic sum of vector form is known as a net force acting on this mass. So that way we have the force acting on the mass m1. Understand? Next question. Is it appearing to you? Tell me the next question.
The atmosphere is held to the earth by gravity.
The atmosphere is held due to earth by gravitational force. Earth by gravitational force, that is first option. Next, name of the fundamental force which holds the planet in their orbits around the sun. What is that fundamental force? What is that force? What is a gravitational force? So this way we have the electrostatic force of first action between the charges. Just now I discussed that. Nuclear forces between the nucleons. Nucleons means the particles present in the nucleus. Whereas if you see, this is a atom, this is a nucleus. Inside the nucleus, protons, and next what is present? Neutrons are present inside the nucleus. Whereas outside the nucleus, what are the present? Electrons are present. Between this one and between nucleus and this electron, electrostatic force will act. Between this proton and neutron, what forces will act? Nuclear forces will act. Between the masses, what kind of force will act? Gravitational force will act. That way we can define. Next, one more slide I'll share. One more slide I'll share. One more slide I want to share for you. Yeah. Next, is it appearing to you?
Yes. Yes, sir.
Yeah, now start doing. Yeah. If the distance between the objects increases, then gravitational force between them is decreases or increases? Distance not remains same. Here, look at here, gravitational force between the two objects are what is the thing? F is equal to G m1 m2 by r square. Here r is nothing but distance between the masses. So when this is increases, this would be decreases. When this is increases, this f value is decreases. Since what is the answer here? What is the answer? If the distance between the object is increases, the gravitational force between the objects will decreases. That is our answer. Next, the acceleration produced in the motion of the body under the effect of gravity is called acceleration due to gravity. That is second option. The value of G is maximum at poles, maximum at equator, same everywhere, minimum at poles. So what is the answer here?
Maximum at poles.
Maximum at poles is the correct answer. Next, the value of G at the center of the earth is, the value of G at the center of the earth is how much? 0, because there is no mass. When there is no mass, no gravitational force, no pulling force, no acceleration. Next, if the speed of the rotating of earth is decreases, then the value of G increases or decreases? G speed, see, so G is equal to this equation we can explain, this thing we can explain. G is equal to G of 1 minus, tell me Bob. So what is the equation we have for rotating body and gravitational force, acceleration due to gravity? What is the equation we have? Already I given that. Tell me Babu. G r omega square cos phi square. What is that? G of r G naught 1 minus r omega square cos square phi. So this is the equation already you know. So when this omega is increases, when omega increases, this value increases, this value will become decreases. So answer is what for here? Answer is what? So decreases at the equator, increases at the poles. So here decreases at the pole. So the thing is decreases at the equator is correct answer. Decreases at the equator is correct answer. Next one, if the mass of the earth is increased by 1% without changing in the radius, then the value of G will be. So value of G will be. So what is the mass of the earth and the acceleration due to gravity relation? You know, G is equal to, you have the relation as G is equal to, small g is equal to capital G m r square. This is the acceleration due to gravity and mass relation. As we are not changing what? We are not changing the G and radius, so this is constant. So acceleration due to gravity is directly proportional to mass of the earth. So now we have to do, take log on both sides. Log G is equal to log, so here G is equal to K into M I am taking, here K is a constant value. Take log on both sides. If I take log on log G, log of Km, so log G I can write as log K plus log M. So differentiate this total equation, you will get delta G by G, differentiation of this term becomes 0, log M nothing but delta M by M. Here finally what is the thing? Delta G by G is equal to delta M by M. So what is the thing they given? How much is the value decreases here? Mass of the earth is increased by 1%. Then, so mass of the earth is increased by how much percentage? Delta G by G is increased by 1%. Then acceleration due to gravity also increases how much percentages? The value of g also increases 1% only. So what is the answer? B. Option B is the answer. Next, when a spaceship is at a distance equal to the Earth radius from the center of the Earth, then the gravitational acceleration is. Where is the when a spaceship? Okay. See, what is the g value at height? What is the g value at height? G is equal to g of 1 minus 2h by g. 1 minus 2h by g is equal to g of 1 minus. So this is r kada r. So now he is telling that when a spaceship is at a distance equal to Earth radius, which means this h value is equal to r, then 2 into r by r. So it would be what? How much? H by r, 2h by r, we have the answer. Formula. H by r, 2h by r. Depth, variation of the acceleration due to gravity with depth, with height. What is the height? With height. Tell me, Babu. Or else you can take one more formula. You can take this formula. G is equal to Gm by R square, this is 1. And G at H is equal to G capital M by R plus H whole square. So take the ratio, take the divide 192, this is GH is equal to G capital M by, this is equation 1, this is equation 2, both equation 1 and 2, G by G H is equal to, what will cancel? Gm by R square upon Gm by R plus H whole square. Gm gets cancelled. What is the remaining thing? G by Gh is equal to R plus H whole square by R plus H square whole square by H kada R square. Next, G by GH is equal to R is G by GH by G is equal to wait, I am doing wrong. G by GH is equal to what is the thing? R plus H by R whole square. So finally G by GH is equal to 1 plus H by R whole square. So now this thing, if I use G value, G only you can take, GH is equal to 1 plus H is R by R whole square. Totally what is the answer we have? G by GH is equal to, G by GH is equal to 1 plus R by R is nothing but 1 whole square. So G by GH is equal to 2 square is 4. GH is equal to G by 4. G by 4 means G value G by 4. Decrease it to how much time? 4 times. Which would be how much? If it is 10 now, if it is decreased to 4 times means what is the answer we have? 2.45 is your answer. Understand? So next other things. Now next do it. Yeah. Next 17. The quantity of matter contained in a body is called. The quantity of matter contained in a body is called. Yes. The quantity of matter contained in a body is called mass. The SI unit of weight is. The SI unit of weight is not kilogram. It is Newton. Force. Weight is nothing but force mg. Weight is nothing but mg, mass into acceleration due to gravity. And next, all bodies falling towards the earth under the action of gravitational force of earth alone are said to be what? Alone are said to be what? Free fall. Mass of the body does not depend upon shape of the body, size of the body, state of the body, all these above. So all these above. All the above is right answer. So I will go for the next slide here. The next slide is this. Is it appearing? Oh, I shared on the same page, kada? No. This is the questions. The weight of the body depends upon. The weight of the body depends upon. The weight of the body depends upon mass of the body. Yeah, it is right. The value of the acceleration to gravity. This is also right. Shape of the body. This is not correct. So both A and B. Both A and B are the answer. Next, Ardman out type. Place, mass, shape, size. Place, mass, shape, size. What is this place, mass, shape, size? Actually, these are representing that. These are the representing that independent of the mass. This is representing the dependent quantity. So that what is the answer? B is the right answer. Next, attractive force, weakest force, conservative force, independent of Newton's third law of motion. Which one is correct? See, attractive force, weakest force, gravitational force. These all three are representing you about force. What kind of force? Gravitational force. This is not representing about gravitational force. That is your answer. Understand? And the next, if the distance between the two bodies is reduced to half, the force of gravitational between them. See, yeah, you can use the formula for having for solving this problem. That F is equal to G m1 m2 by r square is your force between the two masses. Formula for force between the two masses. But what he said, the distance between the bodies are reduced. So this is a body, this is a body. Initially they separated at r distances. Now in the second case, the same bodies, this is m1, this is m2. Now the same body, the distance between them is become now what? R by 2. So how much is the initial value to final value they are asking. Initial value is this. After decreasing the value, you can take f dash. F dash is equal to G m1 m2 by this will be r by 2 whole square. So f dash is equal to G m1 m2 by 4 r square. But what is this thing? This thing is nothing but f kada. So f is equal to 4 times of f. So f dash is become what? 4 times of the answer. What is the answer here? Increased by 4 times. So that is your answer. Next, the ratio of the SI units to CGS unit of G value. So what is the SI units? SI units are G value, capital G value is Newton meter square per kg square kada. So Newton means mass into acceleration, which means kg meter square. Kg meter square sorry, Newton means kg meter per second square. So this is meter square per kg square. So 1 kg gets cancelled. Remaining thing is what? Remaining thing is what? Meter cube by second square per kg. So 1 meter is equal to how many centimeter?